Engine start. Oil pressure, check. Tandem power, 48 volts. Directional signals, check. RPM increasing, check. Navigational devices on and locked. Beacon lights on.
Hello and welcome back to another day. So guys, today I have decided to give you people a very short briefing on how we navigate the ship. So before going into the definition of navigating the ship, we have to understand what is the navigation. So navigation is just a process, or it's like a method of taking a ship from point A to the point B. There are different methods of taking the ship from one point to another. We are having the great circle sailing, we are having small circle sailing, we are having parallel sailing, we are having rhumb line sailing. So it depends on the situation to situation, and if you are going like from the long voyage on the same latitudes, I mean like we are coming from the Europe to the USA, so normally we are doing the long circle sailing way. So I will not go in much detail about that one. So on ship, the navigation is done on the bridge, or also we call this one as a ship operation center. So today I'm going to give you a short briefing about the equipments which we are having on board on this ship, and I'll little bit tell you how we are using these equipments for the navigation of the ship. So just stay with me. So guys, this is our bridge from where we are navigating the ship. So I'll start from this corner. Basically this screen and this screen, we call this one as IVCS system. IVCS system is basically the overview of all the controls of the ship. We have the controls here for the main engine, we have controls here for the auxiliary engine, we have here the control systems for the fuel system, we have here for the lube oil system, we have here the cooling water system, we have here the blast system, build system, like all the controls we are having on this system, and most of them, they are related to the engine room. Beside the IVCS system, this is also the IVCS system, and this one is the blast system. This one is basically, it's like showing the tanks of our ship. Now what is the purpose of this blast tanks? The purpose of blast tanks is for the stability of the ship. Ship is like floating in the water, freely floating in the water. So wherever you put the weight, the ship will sink toward that side. So if you put the weight in the forward of the ship, the ship will sink in the forward. Or if you put the weight in aft of the ship will sink in the aft. So it's like freely floating. So we are using these tanks. These tanks are basically filled with the water. So we are filling or refilling, or we are just emptying these tanks to stable the ship according to our need. So this one is our blast system. Beside this one, because we are having total 5 generators on our ship. 3 of them we are having the main generators, and 1 is our emergency generator, and last one is our shaft generator. Now, okay, other generators you already know, it's like same. But what is shaft generator? The shaft generator is basically, we are having the shaft of the engine room of the engine, which is rotating when the ship is moving. So we are putting the generator on this one, the shaft on this one. This one is basically working on the principle of induced EMF, induced electromotive force. So when this generator is, when the shaft is moving, rotating, so it is producing electricity by the effect of induced EMF. This one is the control of our funnel from where the exhaust gases are coming out. So basically, in the exhaust gases, we are having the oxides of nitrogen, and we are having the oxides of sulfur. So basically it is telling us the amount of oxides of nitrogen and sulfur coming from the exhaust gases of the ship. In other ship we are also having the system of scrubber system. Scrubber system is basically, it's like when the waste gases are coming up, so they are washing these gases with the water. So when this gas react with the water, so the harmful substances inside these exhaust gases like nitrogen oxides or sulfur oxides, they are removed, and only the steam is remaining there, which comes out in the air and which is safe for the environment. Also, you people know that the sulfur oxides and nitrogen oxides, they are dangerous for the atmosphere, and they are also the causes of the acid rain. That's why to eliminate nitrogen oxides and sulfur oxides, we are using these system. So guys, after that we are having this is our radar on ship. Basically we are having, sorry, I just have to adjust the brightness. So guys, after this system we are having the radar. Basically, radar is used for detecting the targets. The basic principle of radar is that it is sending the ultraviolet radiations, and these radiations are when they are touching, or when they are touching any metal objects, they are coming back, and they are the radar is calculating them as a target. Actually, radar is not calculating them as a target. The ARPA is calculating this object as a target for the ship. Or if this target is moving, so it will also tell us with how much speed it is moving, in which direction it is moving. So it will tell us, the ARPA will tell us complete information about this one. Now basically we are having two types of radar on ship. One is called as X-band radar, the other one is called as S-band radar. This radar which we are having, this one is X-band radar. The X-band radar is basically used for the small range, but it will be used in the small range, but it will detect very small objects. And because the wavelength of this radar is very small, so when it will whenever it will encounter with any small metal object, it will detect this target. We can also increase the range and range of this radar from here, and we can make it up to 96 nautical miles. After radar, this is our coning display. So coning display is basically giving us some information, like on the top we are having here the wind speed, then we are having this rate of turn, then we are having date and time, our position. This one on the top, it is giving us the speed of the forward of the ship. The below one it is giving us the speed of the stern of the ship, that is the back of the ship, and the middle one is giving us the forward and aft speed of the, like with how much speed the ship is going forward, or with how much speed the ship is coming behind or aft. So this one is basically giving us the speeds, and then below we are having this one is the information from the echo sounder, with how much depth we are having, so it will be displayed here, and below we are having information about the ETA and other information. So after radar, after coning display, we are having this one is called as telegraph. The important thing, from here we are controlling the speed of the ship. Either we are going forward, or we are going stern, or we are going forward. So from here we can control the speed of the ship. We are also having here the repeaters for the gyro compasses. Basically we are having two types of compasses here. Compass is used to tell us the heading in which the ship is going, or the course in which we are going. So basically we are having four types of gyro compasses, and four gyro compasses, and one is our magnetic compass. Magnetic compass we are using as a backup system. This one is called as, this one is our VHF, very high frequency radio, which we are using, and this one is our public announcement system. This one we are, from here we are we can switch on or off the pumps. And this one, my most important thing on the bridge, my favorite thing actually. So this one is this one is when we are because we can navigate the ship in two ways. Either we can navigate it in the autopilot mode, or we can navigate this one on the hand steering. So from here we can, this is the system for the autopilot. Okay, now this one is on the manual. If I switch this one here to the auto, so it will be converted to autopilot. So just what I have to do, I have to set up the heading in this one. Okay, if I like to go in 351, heading, so ship will maintain this heading on autopilot. But when we are coming to the port, we are switching this one from auto to the manual, and we are using the hand steering. Behind hand steering, you have to learn how to do this one. It's like need of the time and need of the practice. It's not coming very easily, and this like it's very complicated thing. I cannot tell you in this video that how to do the hand steering. It's like much complicated. I will not go in much detail. These one are control of the bow thruster, and the forward we are having small. So we have small propeller, small fans. So we are using this one to maneuver the ship quickly from one direction to the other. So it is like using this. We are using this one. This one is our VHF. We are having one VHF here. We are also having other VHF here, and this one is RPM. RPM means revolution per minute. So it is giving us how much revolution the propeller is moving. I mean, so how much revolution it is moving in 1 minute. So we have on the other side we are having the X-band radar, and here we are having the S-band radar. So the principle is same, but the only difference between X-band and S-band is that in X-band we are having small pulses, but in S-band we are having big pulses. And one important thing about this radar is that we are using this radar in the long range. On the other side we are having this X-band radar, S-band radar. We can use this radar in for both. We can convert this radar for into S-band or X-band. We can depend on our choice. So one more important thing about the X-band radar is that we are having the SART. The SART is that search and rescue transponder, and this SART is working on the frequency of 3 gigahertz. 9 gigahertz, 3 centimeter, 9 gigahertz. The frequency of the SART is 9 gigahertz. The frequency of X-band radar is also 9 gigahertz. So if somebody is sending distress signal from the SART, it will be received on the X-band radar, because both are having the same frequencies, and the pattern of this search would be 12 dots, okay, like 12 dots in the line, and the dot near to your ship, it would be the center of the distress of the ship. So this is one of the most important point about X-band radar is that it is working with the SART. So beside S-band radar, we are having this because this ship is very long. The end is like there, and behind is also so much long. So we have CCTV's cameras all over the ship. So we have the control of CCTV's cameras. So guys, we have on this screen we are having the ACDIS. ACDIS mean electronic display and identification system. So basically, before we were having only paper charts, but now we are having the ACDIS. The ACDIS is basically, on this ACDIS we are preparing our route. Like here, this red line, you can see it's the route. So we are preparing our route here, and from here we can also monitor our route. So all the information we are having here, like the position, course of down, speed, ETA, so everything we can adjust from here. So this is the last display from all the system of the bridge. This one is the same screen as I show you on the other side. So it is giving us the same display as we are getting on the other side. So we can set according to our convenience. So guys, on this side we are having our chart room. Okay, this one, as I show you, we are having the electronic chart on this side. So we are having the paper chart on this side. We are also having one electronic chart here. This one is basically our working station, where the second officer who is responsible to make the route. So he's working over this system, and he's preparing the route, preparing the passage plan on this system, on this electronic chart or ACDIS, and then he's transferring from here to there. So it's not easy job. It's like you have to gather so much information. And this one is our paper chart, and here we are having the logbook. and beside the logbook and all of these things, we are having here two GPS systems. GPS, as you people know, global positioning system, and below we are having this Navtex receiver, navigational telex, and this one is our eco sounder, which is giving us the depth of the water. This one is AIS, automated identification system. Okay, it is giving us the about the information of the ship, and also from here we can send our information to the other ships. And this one is distance indicator, that how much distance we have covered. Normally we are resetting it from every port. This one is our speed log. Okay, from here we can we just it is calculating the speed, so it is then sending to all the system, because all of this system, they are integrated, they are connected with one another. Then it is sending to the other ship. From this one is the master clock of a ship. So if we have to change our time, we are changing here, and in all other ships of the other part of the ship, I mean other clocks of the ship, the time will be automatically changed. This one is our because we are also having the display here for the eco sounder, and this one is giving us the depth of the this one is the printer for the eco sounder, so it will keep on giving us the depth with the passage of time. So guys, this was the short review of all the bridge equipments, and now I'm going to show you the last part here. This one is our GMDSS station. Okay, global maritime distress and safety system. So here we are having the MRSAT C1, MRSAT C2. We are having two MRSATs. MRSAT is basically international maritime satellite, so it is sending us the weather forecasts. And here we are also having the printer for the MRSAT, so it is printing the weather forecast every hour, or sometime it according to when they are sending the new updates, so it will keep on printing. This one is our GMDSS logbook. Okay, this one is our MF, MH and HF, medium frequency and high frequency. So this one is that one. On the other side we are having the very high frequency, and this one is the medium frequency and high frequency. So guys, this was the short tour, and one last thing is remaining. This one we are having like a small library. We are having the collection of books, but one important thing, that it is not like you are coming here and okay, you like to read, and you are just coming here and spending your time like by reading the books. These books, they are one of the most important books which every navigator and every navigation officer must read, because these are not the books, these are the regulations, and every year we have the new regulation coming, because what we are doing on the ship, we are doing it with some kind of regulation. We cannot do anything by our own. Okay, we are having two types of radar. It is by regulation. We are having anything on the ship. Even I told you very simple example, the logbook. So we are writing this logbook according to some regulations. Or we are throwing the food waste at sea. So this one, food waste which we are throwing at sea, this one we are also throwing according to some regulation. I mean, the regulation said that this food waste which you are throwing at sea, it must be grinded up to certain limit. But we cannot like throw, okay, we can throw the whole. No, we have to grind it, then we can throw. And we are having special areas where we can throw, where we cannot throw. So everything which we are doing on ship is by coming by some regulation. Even these gantries are working, these containers are coming and going. So this thing also by some regulation. So we have the problem here for the navigation officer is that they have to study too much, and it's not like you are coming and you are just you will start learning navigation and you will become navigation officer. No, it's a very long journey, and especially for the newcoming cadets, I would like to say them that be ready for the hard time, because it's not like a very easy job here. You have to study, you have to work very hard, and you have to go through rigorous training, and after that you have to go through some theoretical work. You have to pass the simulators, you have to pass some oral exams, you have to pass written exams, you have to go for number of courses. So it's too much. After that you are becoming officer. So you have to be motivated. The good time is coming, and this video was especially for the upcoming graduates who will pass out from the academy. And I would suggest them, I would give them good luck, and I would just say them that may you have fair winds and calm seas and bon voyage. Thank you very much for watching this video.